Alright, let's take a look at our little comic here. It says, meet my son Lester. He just graduated from MIT with honors as an engineer. And then this guy says, see, I begged you that you would learn long division. So, let's learn some long division. This is something that you probably did somewhere, I don't know, maybe 4th, maybe 5th grade, maybe 3rd. But we're going to do with polynomials, but first we'll just review it in general with you and then go over it. So the way long division works is we are going to divide our value into this number, and you just look as to what it can divide into. So 3 goes into 16, 3 times 5, and then we always subtract. So 16 minus 5 is 1. So there's a remainder 1 there. And then what we do is we bring down this number, and so down it comes, becomes 13. So now we say, how many times does 3 go into 13? And it goes 4 times. 4 times 13 is 12, and then we're subtracting again. We got a 1 remainder. And then we bring down the next number here, and we get ourselves a 2. And 3 times 4 happens to be 12, and we get a remainder of 0. Now what I want to really emphasize to you is that 3 and 544 are factors of 1632. Do you understand what I'm saying to you there? Is that by dividing, what we got were factors. So again, factoring and factors is a very important thing, and by dividing, using this division technique, you can find factors. So let's try this next one. 5 doesn't go into 2, so it goes into 28, and it looks like 5 times, and you get 25. Always subtracting gives me 3, and then bring down the 5. 5 times 7 is also 35. Gives me a 0. What that means is that 5 and 57 are factors of 285. So division, long division, generates factors. Now not all numbers divide into each other. Let me give you that example. So let's try this one. 4 goes into 29. Let's see, 7 times? Yeah, 7, because that gives you 28. And then if you subtract that, you get 15. 4 goes into 15 3 times, gives you 12, a remainder 3. So in other words, what we just learned is that 4 and 73 are not factors. They are not factors because they do not divide into it cleanly. All right? Now let's show you how this applies to what we're interested in, which is breaking down large polynomials into smaller ones. So instead of us dividing 4 into 295, which is, I don't know, 3rd grade, we're going to divide things like x plus 2 into x squared minus 2x plus 4. But the idea will be the same, and I'll show it in the next one. But basically, we're going to take this guy and divide it into this guy to see if it divides into it cleanly, and to see if there's a remainder or if we get a factor from it. I'll demonstrate that in the next video.